Hello everyone. So today's POD of lead code is given as longest square streak in an array. So we are going to solve this problem. And in this problem it is given that you are given an integer array nums. A subsequence of nums is called square streak if the length of the subsequence is at least 2, and after sorting the subsequence each element except the first element is the square of the previous element. So we have to return here the length of the longest square streak in the nums. If we are not getting any, then we have to return -1. So yes, we have to find out a subsequence of at least length 2, and let's see the example 1. So here in example 1, it is given nums is equal to 4, 3, 6, 16, 8, and 2. And after choosing the subsequence 4, 16, and 2, we can see that 4 is square of 2 and 16 is a square of 4. So we have a square streak of at least length 3. So here our maximum subsequence length is 3, right? So if we go for example 2, then we can see there is no such square streak. Each and every element is single and it is not running to its square number. Like 2 is not having its square, and 3 is also not having its square, 5 is also not having. So similarly 6 and 7 is also not having its square inside the nums. That's why our answer is -1. And yeah, let's see the constants. So constants given here is num's length can vary uh, from 2 to 10 to the power 5, and the num's value can vary from 2 to 10 to the power 5, right? So if we see that the constants are 10 to the power 5, then we can think like, yes, the solution cannot be any square of time complexity. It should be less than that. So let's try to think on that perspective. So what will be the approach then? So here we can see that we need a value, and then we have to proceed with its square number, how many square streak we can get inside the nums, right? So what if we keep all these elements inside a set, and we will just fetch whether our square number of current number is present inside our set. If yes, then we will increase our square streak, and if our square streak is more than 2, then we will consider maximum of all the streaks, right? So this can be done. So we can think of using set, and we will traverse inside the nums such that whenever we are getting a number, we will get to all the square number possible inside the nums, and we will check whether these numbers square numbers are present inside our nums or not, and we will mark all those visited, all the numbers which where we are getting the square numbers. So all those square numbers will be marked as visited, such that whenever we are coming again inside the nums, we will not deal with that number once again, right? So this can be done using a set. So let's try to do this problem using set, and we will try to optimize further if possible, right? So here firstly we will take n is equal to num start length, and we will keep a set. So here we will keep a set of integer. Set is equal to new hash set, and inside this we will feed our nums value, right? Now we will traverse inside our nums. First of all, what if we will sort this? Can this decrease our time complexity? Let's think about it. So if we will sort our nums, then it will be like 2, 3, then 4, 6, and 68, and then 16, right? This will be in that order. And whenever we will traverse inside these nums, then we will mark that according to the fetching from the set. So I don't think sorting is very helpful or do impact anything, because we are just fetching from the set whether the square number is present inside the set or not. So sorting will not help us anymore, so we will not sort it here, and we will just traverse in the nums. So int I is equal to 0, I less than nums dot length I plus plus. Wait a second, this can be replaced with n only. Yeah. So here our set is taking care of the number present inside the nums, right? Nums array. Now we have to check if a number is already visited, means if it's a square root is already visited, then there is no need to visit it again because it has been covered earlier, right? So that's why we have to take care whether it is already visited or not. So let's keep this set name as is existed, such that we can keep track of what are the numbers present in the nums. So existed numbers will be kept inside this set, and we have to keep track of one more set, and we will keep the name of this set as is visited, right? So here we will check if is visited dot contains our current number, nums of I. If it is already containing, then that means that the number is already covered. If it is not covered yet, then only we will go and search for its square number. So that's why here we will make it as negative, right? And here we will uh, go inside this, and while we are getting the numbers inside the is existed set, we will just make sure that our value should increase by multiplying by its own, so that its square number can be tracked, right? So here we will make one value which is int value is equal to nums of I multiplied by nums of I, and we will see whether this number is existing inside the is exist set. So value, and here while this is containing inside is existed set, we will just make sure that our value should get doubled, not doubled but squared each and every time. And each and every time we will keep track of whether how much square streak we are getting, right? So here the square streak will initially be 1, and it will be incremented as we are going squaring it, right? And after that we will just check whether temp value is greater than 1 or not, because we need the subsequence length is at least 2, right? That's why we have to keep this if condition, and we will make sure our answer should be updated based on maximum number. So temp or max, whatever the maximum value will be, that will be updated in the answer. Initially our answer should be equal to -1, because if in condition of not getting any square streak, we have to return -1, it is given. That's why initially its value will be -1, right? And after that we will just return our value of answer. Okay, so these are uh, the things we should do in this problem. But if we see that our nums of I is having value of 10 to, can vary from 2 to 10 to the power 5, and if we multiply 10 to the power 5 into 10 to the power 5, that can exceed integer range, right? So how can we check those numbers? Those numbers should be inside long range, right? So instead of taking integer range, we will take here long range, here also long range, and we will make sure that whenever we are fitting this value inside our set, then we will make sure it is a long type, right? And here also we have to keep make it as long type, and here also we have to keep it as long. Now let's see whether this is running correctly or not, otherwise we have to debug something. Okay, so our approach is accepted here. So let's try to submit and see how much percentage of this is bidding, and we will try to optimize it further. Okay, so here we are getting 68 percentage. It is beating 68% of the total solution submitted. So let's try to optimize it further. Let's suppose uh, here we are taking sets, and we are here running inside each and every value of nums, right? What if if we see the constraints, so we can see that nums length can vary till 10 to the power 5, and nums of I value can be 10 to the power 5. It means that our range of square cannot exceed 10 to the power 5, right? So whatever the value we are visiting, that will be less than 10 to the power 5. So we will make sure that we should include arrays instead of sets, such that each and every index we can traverse while going to the square numbers instead of keeping a set. So let's try to do it with arrays, such that our fixed number of range can be traversed easily, right? So here we will keep track of max range as 10 to the power 5. So it is 10 to the power 5, and we will keep track of these numbers using arrays, such that index values can be visited or existed or not, that can be tracked, right? So here we will keep track of these. So is existed is equal to new int max range plus 1, and similarly we will keep the value of is visited, right? Now here we will just, here we do not need to make it as long. Why? Because here we are just going to traverse all the values which are integer for sure. We will not exceed these, because these are falling inside 10 to the power 5 range only. So whenever we are going to traverse these, we will mark these as 1, otherwise these are already 0, right? So here instead of traversing in the nums, we will just make sure that we are going to traverse inside max range, and we will multiply each and every time the whatever the numbers we are at present, right? So if some number is already visited, right? If some number is already visited, or it is not existing in our norms, then we will just make sure we will continue to another number. So here we will check whether it is not existed. If it is not existed or it is already visited, then we will continue. So yes, now we will check whether it is visited or not. So here we are not traversing inside the nums value, but instead we have kept all the nums value inside our is existed array, and we are traversing in the range of 1 to 10 to the power 5, and each and every time we are making sure that all the square numbers getting traversed if that is existing in our is existed array, right? So here our value will be inside the nums, inside the in the range of integer only. And here we will check whether our value is greater than or equal to 0 or not, and our value is less than or equal to max value or not. In that condition only we will check whether our existed array is containing our value. If that is the case, then only we will we will multiply our value to its own such that it get squared, and we will check again and again for square streaks. So these are the conditions should be maintained, right? And yes, so this is how we are going to make sure that each and every time we are just considering whatever the numbers we are trying to get all the numbers which are squared and if it is present in our array. So this is little bit of optimized. So yeah, let's try to submit it and we will see what is the time complexity and space complexity it is taking. So it is more, it is showing that it is more efficient than previous one. So in case of set, whenever we are feeding the values inside the set, it checks whether collision occurs or not. While in case of arrays, there is no need to check whether collision occurs or not. It is directly containing the values inside the index and operating with the indexes. That's why this solution of arrays is more efficient than previous one, the set one, and its time complexity is very constant, which is 10 to the power 5. And as our range is fixed, it can be considered more about constant, while in case of set our there is no constant thing. We are taking n is as our range of traversing the arrays, and this is why this solution is more efficient than the previous one. So this was for today's POD. I hope this was helpful to you. Thank you.